All right. Now, good afternoon, ladies and gentlemen. Uniform circular, simple harmonic motion, lesson 4. Okay. Now, here, this is sort of a repeat of the first lesson. When you have a spring and you pull on it, what happens? It stretches. So F is kx. And remember, energy potential, kx squared. Now, that's nothing new there. Oh, they might call it Ka 1/2 Ka squared for amplitude. I'm having a brain fart whether the textbook that you never read uses X or A. I think they use A, but it doesn't really matter. I try to use A in this lesson, which means I'll probably flip over and use X occasionally just to confuse you. All right, so I pull this spring out 45 centimeters. Yep, from the middle. Displacement is 45 centimeters, and K is 110 newtons per meter. Because in the middle, it's at equilibrium. There's no net force, no acceleration. Go to Miss Monique's room. I want you in there. Okay. Now, where was I? Yeah. Spring constant 110 newtons, and you pull it 45 centimeters. What's going to happen? It's going to go wee. Don't be standing here because it's going to come back at you. Now, not the new thing, but the thing I want to stress today, energy total is energy potential plus energy kinetic. So in the first lesson, we were at one end or the middle. Here, we're going to be in the one end, the middle, or somewhere in between. So looking at this spring, what can we say about it? Look at the mass just as we let go of it. It's kind of like a slingshot. What can we say about it? It has what? Sorry? It has, just as we let go of it, how fast is it moving? 0. So right at the beginning, velocity initial is 0. So it's straight potential energy, which is 1/2 Ka squared. So can you guys tell me the total energy of this system? Calculate it for me. Do you want to do it on slates or on your paper? Paper. Okay. So 1/2 Ka squared. What's my trick? Centimeters? Should be meters. Yes. Should be meters. So somebody, thank you for volunteering. Ryan, grab your calculator and tell me. Yes, now. Make it work faster.
24.75.
1375 joules. Held 11.14 joules. Now, typical question. Now, the next typical question would be, what's the velocity? What's Vmax? Now, I want to stress something here. Same system. So this is question A. Question B is Vmax. So what's the maximum velocity of this thing? Well, here you got to go back. Springs, forces, it's like a slingshot. Where's the maximum velocity? Oh, sorry. What's a nice mass?
1.
All right, 1 kilogram. All right, you're right. I need to give you the mass. My bad. Now, where is the maximum velocity? Come on. When you're pulling it at the end, or actually, sorry, this way, and you let go of it, what happens?
Isn't it as fast as just before the spring starts to compress?
Yes. Where's that? In the middle. So when x equals 0, you've got Vmax. So E total, EP, is Ek. Now this looks a whole lot like conservation of energy, kinetic and potential energy we did a few lessons back. You drop a rock, what's its velocity at the bottom? What's its velocity? What's its potential energy at the top? Same thing. Same idea, slightly different formula. Now, we just said x or A is 0, so energy potential is 0. A equals 0. So this is 1/2 mv squared. Now, I told you the mass is 1 kilogram. How do you calculate the velocity? For what? What do you know? What's your energy total?
11.14.
Yes, 11.14 joules. That doesn't change. So, y'all, oh God, all of you, y'all, more coffee. Anyway, you're right. We've got to rearrange this for v squared. It would help if I could actually see the formula we're trying to rearrange. There we go. 11.4 energy total, 11.14 joules is 1/2 mass velocity squared. 1/2 times 1 is? So how do I get rid of times 1/2? Yes, divide both sides by 1/2 kilogram. I'm down to v squared is 22.28. Whatever the heck a joule. Actually, that's meters squared per second squared. So what's the square root of that?
4.71.
I'm going to go with what the lady said. Yes?
The Vmax equals amplitude square root K over M.
Mm-hmm. Sorry?
Yeah, it's the same as.
Okay. That works. Now, I'm perfect. Oh, yes. Thank you. What's the Vmax formula I gave you?
Amplitude square root K over M.
Now, a few lessons back in simple harmonic motion, or no, sorry. Yes. Lesson 1, I gave you this formula, Vmax. Now, this always works, maximum velocity. Right? So, yes, you can use that. The trouble with that is, my third question is going to be, it keeps on going, and now it's 15 centimeters in from the origin. What's its velocity? Yes. Somebody wasn't paying attention and has their hand there. How hard is that thing going to hit their hand? How fast is it going? Not their teeth, their hand. Now, if you're dumb enough to put your hand there, anyway. Yes. Smile! Anyway, I shouldn't say that in front of the camera. It's like a pain in the bum to edit that out. Anyway. But I don't because nobody ever watches the video. I should shut up. All right, now, here's the thing today. Vmax. Well, I am. It's not the maximum velocity. It's the velocity in between. So here, energy total, energy potential, plus energy kinetic. What's our total energy? 11.14 joules. What's the formula for potential energy? It's gravity. With a spring, it's K. I'll call it Ka squared if you don't mind. Now, do we know K? Yes. Do we know A? Yes. Do we know M? Yes. Can we solve for V? Yes. This is today's lesson. You get the entire equation and you have to solve for something. Yes, it's the only thing we don't know. If you can get this, that's basically it. I'll do one more example question and realize we could solve for K or A or M or V or E total.
So what's our K?
Still the same 110. Oh, still the same 110 newtons per meter. Okay. And what's my amplitude? .15 from the center. So my amplitude is 0.15 meters. No. But that's a favorite trick question. When it's 15 centimeters in, not 15 centimeters from the origin. But that's a wording question, and I saved that for the homework, like second to last one or something. Okay. So, annoying but quite solvable math question. Come on. So 11.14 joules equals 1/2 110 times 0.15 squared plus 1/2 1 kilogram times v squared. So solvable. Annoying. So Kyle, thank you for volunteering to help. 1/2 times 110 is? Yes. Well, actually, that's the next part of the question. But 1/2 110 is 55. 55 times 0.15 squared is? That's it? Okay. So, so I subtract 1.24 from both sides. So how many joules do I have left?
9.9025.
Sorry?
9.9025.
902 joules, close enough, equals 1/2 kilogram v squared. So I divide both sides by 1/2 kilo. What do I get?
19.835.
So v squared is 19.80 meters squared per second squared. So velocity is what, I'm sorry? What did we say the maximum velocity was?
4.7.
Okay, so it is a little slower. Not a lot. The spring isn't slowing it down a lot yet. It will. So don't put your hand there. Don't put your face there. Pay attention. All right, you guys see how this goes? Okay. One more question just to screw with your mind? Okay. Now. So, I take that spring out and I put in a different spring with a different K. And I note that when I pull it out, "50 centimeters this time," and let it go. When it's over here, 25 centimeters beyond the origin, equilibrium, velocity is 3.1 meters per second. I want to know what K is. Now, this is a sneaky question. If you can, actually, it's not sneaky, but if you can get this, you've got it. Yes? Yes, it's the same 1 kilogram. I changed the spring, so it's a new K. So you're going, oh, crap, Mr. Sutton is being Mr. Sutton again. But he's not. I'm off the evil pills. Yeah. Yes. Actually, I'm just drinking more coffee. So, anyway.
Can you use Vmax equals a, like that?
Yeah, I hadn't thought of that, but Vmax is, hang it, stop, is what? What's the formula?
A multiplied by square root of K over M.
You could. What's the maximum velocity?
3.1?
No. When it's 25, it shoots through the origin, keeps on going. When it's 25 centimeters beyond that, its velocity is 3.1 meters a second.
Oh.
Now, oh, wait a minute. Sorry. Sorry. No, wait a minute. My bad. Hang on a sec, guys. Sorry. You're right. I'd have to give you K to find out energy total, wouldn't I?
Yeah.
Right, sorry. You're right. Let's change Sydney's question. Here at the origin, velocity is 4.7 meters per second. My bad. What's K? That's an easier question. That's a question you can solve. So what's its maximum velocity? 4.7 meters a second. Can you solve for K? You pulled it out. What's your A?
A is
Yes, half a meter when you pull it out and let it go. So V max work on that.
so then 88.36.
Could be. Now, well, hang on. Divide by 0.5. You get what? 9.4 meters per second squared is square root of K over 1 kilogram.
Square
Both sides. And what do you get?
88.36.
K over 1.
Then you multiply both sides by 1, so 88.36.
Call it 88.4 newtons per meter. Okay. Yes, sorry. Thank you for pointing out the shortcut. I was going to make you do it the hard way, but never mind.
The hard way was like if you find
Well, the hard way was, yes, we find the energy and then work backwards. Then I realized you can't find the energy unless you know K to begin with.
Well, can you, yeah, because K is in both.
Yes, then I thought, yes, what happens if we're in the middle here and I give you this?
Wait, well,
Then you can figure out K from that.
isn't kinetic energy,
We have to figure out total energy somehow. So we can figure it out at the far end here. It's just E total EP plus EK. At this point, velocity is 0.
but then can you find it for the other part where there's no potential?
Yes, we just did. Energy total, E sub P plus EK. So energy total is kinetic energy here, but then Sydney pointed out, I showed you the sneaky shortcut. And honestly, if I show you a sneaky shortcut and she remembers it, we should use it. So I was going to make you do here energy total, find the total energy, and then plug that in over here. E total equals EP plus EK, and solve it like that. And then, of course, Sydney found the shortcut and made it all too easy. So I'm embarrassed. So you guys okay with this, or do you want another example?
Okay.
Yeah, it's just sitting there smiling. All right. So this is lesson 4. That's it. If you want to, I am going to do one more. Yeah. Well, I mean, it's one formula. So I'm going to do another example on the board here, just because. But if you got this, quietly work. So if you haven't got this, shush, pay attention. Shh. Yes. Yes. So, here's the last question. And? Done? Yes. All right, slip a Kit Kat inside it and hand it in. Uh-huh. Ryan, get him for bonus points. All right, so you pull this spring back, the new spring, 88.4 newtons per meter. You pull it back 0.6 meters. This is still 1 kilo. Kilogram. Where is it here when velocity is 2 meters per second? That's a good question. Now, I'm going to put this here because I desperately need a glass of water. I'll leave you gentlemen stare at this question. Copy it out. What's the formula you need? All right. So, what do we do first?
Your phone was ringing. Yeah, your phone was ringing.
Okay. It's only on so that I can get the text for the address of the fire. Anyway.
Like the school phone. Yeah,
Oh, and nobody bothered answering. Uh-huh.
By the time I thought about getting up, it stopped ringing. Yeah.
Shh. 2, 4, 6, 8, 10, 12, 14. Everybody's here, aren't they? Yeah. Okay. This is going to be an interesting, dull video. But anyway, so. Louder? Yes, except for Kyle's. So, if you'll be quiet and leave me alone, I'll mark his, and then we can go over them. All right. First, we're going to do this one. Now, what do we do? Shh, ladies. I've embarrassed myself enough as is. E total, EP plus EK. At the beginning here, when we pull it back, zero kinetic energy. So E total is 1/2 Ka squared, which is what? 1/2 88.4 times 0.6 squared. What number did you guys get? Come on. Nobody bothered doing it. All right. Yeah, sit there and grin on your face. What is it? What do I get?
15.9.
Sorry?
15.9.
So 15.9 joules. Okay. Yeah, that's a reasonable number. All right. So here, velocity is 2 meters a second. solving. Shh. I don't want to hear it. I know K is 88.4 newtons per meter times A squared plus kilogram times K. So, solve and tell me what A is. Yes? No, got to stay in the classroom. No, if you've got to work on your catapult, once this is done, I don't mind you going outside to work on it. But June. Yes.
What are we looking for in this question?
Solving for A, the amplitude or distance it's got.
Didn't we already figure out that was 0.6 meters squared?
No, that was at the beginning. We pulled it back to see how much energy total we had.
Oh, okay.
So this is 15.9 joules is 44.2 newtons per meter A squared plus 1/242 joules. So this is 13.9 joules is 44.2 newtons per meter A squared. So, what's 13.9 divided by 44.2?
Is that 2.0, Jay?
Yes, 2.0 joules.
0.3144.
Is that A squared or A?
That's A squared.
A squared. Sorry, one time, Sydney?
0.314. And then this A by itself.
Yes.
0.56.
Ooh. Almost at equilibrium. Yep. All right. Okay. So that's basically how it goes. Now I'm going to turn this off and apologize to the lady in the office.